Okay, here's an example of a while loop. While I is less than testVec.size, um, it'll execute this loop over and over and over again, and we're incrementing I in it. Now, you can easily, if you don't have conditions that lead to a termination effect, you can create an infinite loop. In fact, while loops are often used to create, an infinite, an infinite loop, basically. Shit. Now I need it. Okay, like in Chili's program here, let's see, where the fuck is it? In his Windows routine, I think, in the Chili framework. Main window, CPP, yeah, here it is. I don't know, I could be wrong, it could be somewhere else. Yeah, no, this isn't where it's running the main loop. Let's see, it's where it might be a main. Yeah, right here. It's basically, this is basically amounts to an infinite loop. Um, inside his main, while when processing message is true, it'll implement this. It's not really an infinite loop, but there is an infinite loop in here somewhere. Um, this is our main.cpp file. This is a function that's implemented in main.cpp. So we have a header file associated with it. Let's see a header file for it. Yeah. Yeah, he doesn't have a header file for it, so it's just this file. But this is main function. This is one of the main loops, and while there are messages to process, while that's true, the result of this function is true, it'll, loop through the game loop. So anyway, the point is that let me close this down again. While loop, so you can create an infinite loop, and I've certainly seen instances of that happening. Um, where inside that loop, a user's got to press a command to break out of the loop, or so, press something on the keyboard or click a mouse to break out of it. But there should always be a way out of the loop, even in a loop like that. Um, use similar types of loops sometimes in assembly language. But yeah, basically, it's as simple as that. And what this um, program is doing, I have no clue. Went ahead and executed the code down to here just so you can see what it's doing in case you want to understand the code. The code itself is irrelevant. I mean, this just demonstrates a while loop, and it's working apparently with a vector, something called test.vec. And here it is. It is an actual vector. This is initialized differently than that other one. It said 3, comma 1, whatever. This makes it look like it has 25 elements in it. Fuck, I don't know. Again, without looking at the vector type, as I know this little book I was on when I read this didn't talk about it very much. But it's certainly incrementing a value and setting it equal to I, and we're saying if I equals 3, then skip this, print skip that, and continue, so it'll continue on with the loop, but when I equals 22 it'll break out of the loop. So these are an example of two, keywords you can use inside of a while loop. So you got the continue, because when it hits a continue it'll start the next iteration over again, so it really will skip through. It won't process any more code in the loop. And here it just flat out breaks out of it. So and here's where we're actually printing out what the values are at these various locations as I cycle through them. And here's where I set the value in that location to I minus 1 equals I. So these are the points that it actually printed that. I guess we started at 9, yeah, because I set I initially to 8. So, which doesn't make sense to test for that, but it'll go up to 22, and that's why it's not printing it, because it breaks out before it, assigns it or prints it. So, but we're not actually executing this in this code because I set the I equal to that, I guess, to shorten it up or whatever. I was probably tinkering with it. Let's see. Okay, then this shows you, this loop runs 6 times, this loop runs 5 times, and the difference is this right here. So that's definitely going to be 6 iterations, that's going to be 5 iterations. And this group won't run at all, since it's just equal to 5. So because it evaluates to false, so you can't say when I is equal to a value in a loop like this, because it'll evaluate to false. Because see, the moment this evaluates to false, it'll break out of the loop. So that's what you got to keep in mind. That just proves it. What that statement does. Yeah. Well, I don't want to do that. Okay, I'll go ahead and run it to there, so you can see what it's doing. Final value of I. Wouldn't worry about any of it though. Like I said, you can either declare a value inside a for loop, or you can do it because it'll only be within the scope of the for loop if you declare it here. So it'll be vanish after it's done, or you can use it as an external variable. And it doesn't matter if it's named the same thing. So we have an I here, but since this is in a different scope, you can declare it, but there will be a problem if you need to access that external value of I. So, because there'll be a name conflict there. Because as you see elsewhere, we can use that value, like here, inside of our loop. And we're doing the same thing here. This shows that the local value I may be declared without affecting the value of I in larger scope of the program, at least in a for loop. So in other words, it'll use this value of I, not this value of I out here. But again, that's a problem if you want to use that value of I for some reason inside your loop. because again, you could carry that variable, if this was like J or something, you could still use I inside that loop. Because it's within the scope of your, this scope is within the scope of your main program. So you can include outside variables, but when you declare a variable inside of a scope that's the same name as a variable outside, its parent scope, this value will overwrite the parent scope value. So okay, now we're doing some kind of float thing down here. No, that's fine, I guess. So you can see what these various things did, if you're interested. Okay, yeah, this was interesting. So I should have. This is a do while loop right here. So so in a do while loop, see in a while loop like we did up here, it may not even run the code once, because if this test, is it fails, on the first iteration, well, it'll just never execute any of the code. But here, it will execute the code at least once, because it does its test at the end. So it's do, then while I is less than 90. So it'll run at least once, even if this is false to begin with. But then when it evaluates false, it'll break out of the loop. So while I is less than 90 is true, it'll continue to run the loop. It's just like in a for loop, okay? Where the hell did we... Yeah, in a for loop, as long as this condition is true, it'll continue to execute the loop. But the moment that it's false, like it is here, it'll break out of the loop. So, but again, for loops, aren't guaranteed to even run once either, for the same reason. But a do while loop is guaranteed to run at least once, before it breaks out. So, that's what you see happening there. Okay, well, I guess we hadn't gotten to the do while loop yet. Okay, let's see if there's anything. Okay, this code right here, I think, is just demonstrating a function which is defined below. Now, we probably declared it, and in fact, we almost certainly declared it above with a for declaration. At the very beginning of the code listing. But this just shows functions, and like I said again, you can look through the code as you wish to see how basic functions work, because this is still just very preliminary. But again, these are all passed by value, and which are fine for small functions, but then it does return type, float, and stuff. The functions are pretty straightforward, so I'm not going to cover much of that right here anyway. Yeah, this is just showing you, compute area is another function we defined, which you probably saw in there, and so, again, not really that big of a deal. Recursive function call section, okay. 15. Yep. Some of those using floating point values. C out's pretty versatile like that. I mean, it's a good statement if you're doing console programming. It's a good function to use, because it'll, it's pretty versatile in how it can print and everything else. I mean, printf is kind of too, but it's a little limited. See how it's a little more versatile, a little less rigid, but it's annoying having to do these things all the damn time. So I kind of prefer printf to some extent. Yeah, degrees Fahrenheit is a floating point value. I don't know where you declared all these. Oh, right here. Floating. Yeah. Because see, it's like I said, you can't tell that it's floating, without looking at it. Luckily, there's a value in there you can look at. That's a dead giveaway that it's 15.0000 or whatever. Same here. That's a dead giveaway. But again, you're only going to get that when you're actually debugging the program. You're not going to see that normally. When you're just looking at the code listing, it won't give you that kind of feedback. So, it took that 7.6 milliseconds, apparently. Okay, attempt to do a factorial in a loop. Okay, so this is a program I think I must have written. Number 8. The routine could not run amok and correct the entire system. Yeah, but that's the problem with recursive programs or routines. Are almost impossible to debug, particularly when they start getting complex, which later on I might show you an example of one if I can find it. It'll be in a much later video, though. Jeepers. Because like I said, the routine to find the damn, Fibonacci number is, and I probably will get to that, but in a much later video, because that's pretty recent. Code. I'm doing this code by the date, so this is the first program I wrote, out of that book, and so I got a lot more to go. Hopefully it'll go faster though in the future. After we get this initial shit out of the way. I'm not going to bother explaining this, just that it uses a do while loop. So, to figure out a factorial, the number is greater than 0. But since the number is decrementing, eventually, it'll be equal to 0. So, finally, we're at the end of the fucking thing. Alright, well, actually, I can just go run it now. Since we're got a system pause command there. Alright. So the final factorial of 8, is 40,000 something. Which I might as well, go 8 shift factorial. Yep, 4320. Okay, and that's it for this program, and that covers the loop structures, and and here's all the functions that I declared above, with 4 declarations down here. So again, you know where the program is. Just look at the first video in the set, and let me press the key to continue. Okay, and that'll do it.